Thank you for participating in Morehead at Home Skywatching, hosted by Morehead Planetarium and Science Center. My name is Amy Sale, and I'm an educator at Morehead. We are a unit of the University of North Carolina at Chapel Hill, located on campus, and we also work throughout the state through a number of outreach initiatives like our mobile lab vans, summer camp programs, and the annual North Carolina Science Festival. Our mission is to help people better understand science, technology, and health, and we do this through engaging learning opportunities like this live virtual event. I'll turn things over to Nick, who will explain about today's plan.
Thanks, Amy. And hey, everybody, welcome to Morehead at Home. We're glad you're joining us today. Maybe you saw some of these programs last week, or this could be your first time, but either way, welcome. We're excited to show you some things. So if you did visit us in the last couple of sessions, you'll know that we're using a software called Stellarium. It's kind of like a flat screen planetarium to help us simulate the sky. So before we get into what we're going to talk about today, I'm going to share my screen so you can see that sky as well. Now, I'll go ahead and remind you as I'm doing this, if you have questions, we're going to use the Q&A function that's right down there below you. So throughout the presentation, if you have something you'd like to ask, go ahead and pop it in that chat box. But you should now be seeing kind of funny looking sky, maybe a semicircle with some grass on either side. Well, this is a view that you would get looking towards the south from somewhere like Chapel Hill, North Carolina. So just for reference, if you can see my pointer here, the top of the sky is going to be up here. So imagine you're looking straight overhead. And then if you're looking to your right, when you're facing south, maybe you're looking west. And if you're looking left, you're facing east. But we're not here to look at a daytime sky. Today, we're going to do something called star hopping, which is basically a fun way to move from place to place in the sky. So I'm going to do something interesting. I'm going to move time forward. You might have noticed we have a clock down here at the bottom of the screen. We're going to make that time move a little faster than normal so that we can make it dark. Now, as we do this, you might notice that the moon is labeled and it's almost in the same direction as the sun. So it's going to be really tough to see the moon this morning. This is the time right now on April 21st, 2020, and that moon's phase is a waning crescent. So it's going to be a new moon tomorrow evening. That's Wednesday, the 22nd. So that's why you see it labeled, but you might not actually be able to see it very well in the sky. But you notice as time moves forward, we're getting into the evening sky, and eventually the sun is going to dip below the horizon, and we'll get a look at some stars. Well, the first thing that popped up actually was not a star. The planet Venus is going to be very, very bright this evening. But we're going to do something a little different. I told you when we started out with a southern view, the shape that we're going to try to find today is actually going to help us star hop and point to things in the north. So what I'm going to do is move our sky around. So instead of facing south, we're going to spin around and face the north. I know that can be dizzying, but you made it. And you notice that things kind of seems to move around this top area of our sky. So the shape that we are going to look for is one that many of us have probably found before, and it goes by many names, but you probably know it as the Big Dipper. The Big Dipper is what we call an asterism, a familiar grouping of stars. So it's not actually a constellation, but it's part of a larger constellation. Some people know it as the drinking gourd. I know in England back in the day, they called it the plow. So one thing about finding shapes in the sky is that we have to use our imaginations. So the Big Dipper, to our eyes, looks like a big spoon that you dip into a pot of soup. And to find it, you're going to need to look for 7 bright stars. And I'll tell you, now that we're in this northern view, our Big Dipper is going to look a little bit upside down. So I'll give you a moment just to look kind of towards the center of your screen, see if you can find 7 bright stars. But you know, the neat thing about a program like Stellarium is that we can help you out. Here's one of the bright stars of the Big Dipper. Its name is Merak, but I'm going to bring up the lines that give you the whole shape. So the 7 stars I was indicating are 3 in the handle, 1, 2, 3, and 4 in the bowl, 1, 2, 3, 4. So that is what we call the Big Dipper. But you notice there are some other appendages stretching off of here. Maybe it looks like legs or an upside down ironing board or something like that. Well, in the stories, which we're going to tell you a story in just a couple of minutes, the Big Dipper is part of a larger constellation called Ursa Major, which is the Big Bear. So maybe you see our upside down bear. I don't know about you. I've never seen a bear with a big long tail. Oh, and it looks like a snake is chasing him from the side of the screen over there. Okay. Well, that bear can, again, be seen in many different ways. And to maybe show us another way, I'm going to pass it over to Amy to talk a little bit more.
Okay, so hopefully you have found the 7 stars that form the Big Dipper within the constellation of Ursa Major, the Big Bear. We're going to use every part of that Big Dipper to star hop our way around the sky. So we're going to start by using the side of the bowl. So it's the side of the bowl that's the farthest away from the tip of the handle. If you start at the bottom of the bowl, it's going to look higher up on your screen, but it's actually the bottom of the bowl. That's Merak. And then the next star after that, at the top of the bowl, is Dubhe. And we're going to think of those as the pointer stars. So we're going to draw a line from Merak through Dubhe, and then you're going to keep going. And I like to go Merak through Dubhe, 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 Do, until you hit that star. That star is known as Polaris. It is the North Star, and stellarium represents brighter objects with kind of bigger dots, and you'll see that the North Star, Polaris, is not the brightest star in the sky. It's not famous for being bright. It's famous for being in the north. Okay, so you'll also see that another pattern came up when Nick clicked on Polaris. He pulled up more information about that star on the top left of your screen, and it also brought up another outline picture. And that is known as the Little Dipper, or Ursa Minor, the Little Bear. And got a story for you. And this story does not involve bears. Not everybody around the world has always seen a bear when they looked up at that part of the sky. This is a Southern Paiute story told by people native to what we now call Utah. And they have a story about the North Star being a mountain sheep. And this is how it goes. There once lived a mountain sheep, Naga, who was the bravest and the most skilled of all the mountain sheep at climbing mountains. Every day he would go out and he would look for a new mountain to test his skill and his courage. And one day he saw a mountain he had never seen before, and it was so tall. It stretched up way above the clouds. He couldn't even see the tip of it. And its sides were very smooth and steep. They were like glass. And he circled the base of this mountain, circling and circling, trying to find some sort of ledge that he could get a foothold on to climb it. And he circled and circled, and he finally found an opening at the base of the mountain. He went inside, he squeezed in, and he found that there was a path leading to the top of the mountain. And as he walked up the path, he started knocking rocks down with his feet, and eventually the rocks filled up the opening. So he knew he'd never be able to go back down that same way. So he climbed and climbed. He made it to the top. And when he got to the top, he wanted to jump for joy, but he couldn't. There was no room at the top. All he could do was look around and gaze down at those steep, smooth sides, and he realized he would never get down, that he might die at the top of that mountain. So his father took pity on him, turned him into a star, the star that does not move, which you might know as Polaris, the North Star. And he serves there as a guide to humans to help us find our way. And you might have noticed Nick actually moved the sky around. What was happening was he was advancing time through the night, and you saw the sky appear to turn around Polaris, around Naga. And that is because the North Star acts like a pivot point in our sky. It's above our Earth's North Pole. It stays in the same spot as Earth rotates on its axis over the day and over the night. And so according to the Southern Paiute story, the other stars in the Little Dipper and in the Big Dipper, they are other mountain sheep endlessly circling the base of that mountain, trying to find a way to join their friend at the top.
What a lovely story. So as Amy said, you have noticed that we moved pretty far forward in time. It's about 2:20 a.m., way past some of our bedtimes. But this is what would be high overhead if you look towards the north. Now, star hopping with the Big Dipper, which you can now see is kind of moved over in this direction, is really useful at this time of year. But for our purposes, I'm going to do something that you would never really see in the real sky. I'm going to speed us up, maybe notice how Polaris, the North Star, is still hanging out right over the north. We call some of these shapes and stars that go around Polaris the circumpolar stars and constellations. And just like that, we came to a new day. Well, the whole reason I did that was so that we can kind of hop back to our regular view. The way that you do this to go to right now's time is to hit the number 8 on your keyboard. And you see, just like that, I moved around to right now. We're still facing north though. So I want to show you how things would look if you get back to your southern view. So I know that was a lot of quick movement. We do a lot of time traveling here in the planetarium, in our flat screen planetarium, Stellarium. In order to get you another view of the Big Dipper, now that we've seen a story and star hopped our way to the North Star, I'm going to bring you back to the nighttime. So again, this will look familiar because it's kind of what we did at the beginning of the show today. So we'll move it forward just a little faster for our purposes and get us back to an early evening sky, because when you're facing south, you can still find the Big Dipper. It's just a little bit harder to point to the North Star. So I'm going to pause us here at about 9:40 p.m. And again, this might be a familiar view. If you're wondering where that dipper is, I'll give you a second to look on your screen and I'll point it out for you. Now we're kind of even higher in the sky from our perspective. Here's Merak and Doobie. Here's the rest of the bowl of the dipper and our 3 stars in the handle. So you see why we had to spin around to look north, because we would be pointing up off the screen if we tried to point there right now. But there are things in our sky that the Big Dipper can point us to that aren't the North Star. One of them, in fact, is one of my favorite ways to star hop, because it's imagining that we fill up that dipper with water. It's a very ancient pattern that we see in the sky. So, you know, our big pot of soup gets leaky every once in a while. So what I want you all to do is imagine you poked a hole in the bottom of that Big Dipper. So kind of right in between the handle and those 2 stars, pointer stars we pointed out earlier, we'll poke a hole right in the bottom of the dipper. And imagine that that soup or water is leaking onto the back of a creature that really does not like to get wet. I'm going to outline this for us here. You saw the name pop up. I have one here in my house, and some of you might have them at home too. This is a cat in the sky, a big cat, Leo the lion. So if you're using your imagination, after you've dripped water from the bottom of the Big Dipper, it falls onto the back of a lion. If you're like me, maybe this connect the dot shape doesn't look a ton like a lion. What I look for is a backwards question mark. Maybe you can see that here. And a small triangle that show us the mane and head and the tail and hindquarters of our lion. But you know, if you want to think of it as something different, maybe a mouse whose nose is over here and has a curly tail, or a coat hanger that's all bent up, you know, that's okay too. But let's see how our artist represents Leo the lion. Now maybe you can see that lion roaring up there in the sky. So we call Leo a springtime constellation. It's high overhead here in the spring, and using the Big Dipper and that water within the Big Dipper is just one way to find it. And you notice the bright star that I picked out here is called Regulus. You should be able to see that on a clear night from your backyard here in North Carolina and probably beyond. Now let's move forward just a little bit, because I want to point us to one more shape using the Big Dipper and star hopping with the Big Dipper. As we move time, you might see some objects kind of zooming around the screen. Well, that's because there are satellites that orbit around our Earth all the time. So some of those satellites are what you're seeing zoom by. Here's what we're going to do with the Big Dipper this time. So we found Leo. Go back up to your dipper. Imagine it didn't spring a leak. It's still full of water. We are going to use the handle, the 3 bright stars in the handle of the dipper, to find our way to another bright star in another prominent spring constellation. So I kind of think these 3 stars, they don't quite make a straight line. They make more of an arc. So we're going to follow that arc of the handle of the Big Dipper to a bright star called Arcturus. And if it helps you remember, you can say arc to Arcturus. Arcturus is the brightest star in a constellation called Bootes, the herdsman. And you spell that B-O-O-T-E-S. I know that might look a little funny, but you say Bootes. And I said herdsman, that's somebody who herds sheep. I don't know about you, but this kind of looks like a crinkled up necktie or maybe an ice cream cone or something like that. Maybe it's getting warmer outside, so our ice cream is melting down off the sides of our cone. Well, we'll see what the artist thinks and bring up a picture of our herdsmen. So again, when you look at constellations in the sky, you have to use your imagination. And I know, we're at home right now, but using your imagination with the sky is something you can do, maybe in your back porch, your backyard, your front stoop. Just if you get away from some of those bright lights, you can maybe imagine some of these shapes up in the sky tonight. So remember, we use the handle of that Big Dipper, and I'll outline our Ursa Major for us so we can see it again here. Remember, there's our big bear. We're going to use the handle of that Big Dipper to arc our way to Arcturus.
Okay, so we are using all parts of the Big Dipper to star hop our way around the sky. Remember, you've used the pointer stars, Merak and Doobie, to get to the North Star, which is part of the Little Dipper, which is not on the screen right now because we're showing you more of a southern view, and the Little Dipper's in the north. We've used the bottom of the bowl to get ourselves to Leo, the lion, and then we've used the handle of the Big Dipper to arc to Arcturus. But if you're feeling ambitious after you've arced to Arcturus, you can keep going. You can speed on to Spica. So sort of keep drawing that imaginary line down till you get to a bright star called Spica. And it's part of a constellation called Virgo. Now, Virgo is supposed to be this maiden, this woman, but you can use your imagination. Maybe you see something else. I think with just the outline, she sort of looks like an apron or a flying superhero, but maybe you see something else. So that's how you can star hop with the Big Dipper, and we encourage you to try it. Last time I checked, the weather looked pretty good for tonight for North Carolina. So look for these things, and this program, Stellarium, is free for download for your computer. Go to stellarium.org, STELLARIUM. Or we have Morehead star maps online at moreheadplanetarium.org as well. If you go to the Morehead at Home section, you can find the April-May star maps, and you can do some practice. And Nick, I think we wanted to mention one more thing for those who are willing to lose some sleep tonight. There is a treat that awaits you. So what Nick has done is he has just put up the radiant of various meteor showers. So the radiant of a meteor shower means the place in the sky from which meteors appear to radiate away from. Meteors are sometimes known as shooting stars. They are not stars. Meteors are the streaks of light you see when basically Earth runs into cosmic debris. And this can happen any night. Sporadic meteors can happen on any night, but certain times of the year we run into a denser clump of meteors, and that's called a meteor shower. We have been in a meteor shower drought. There's in the first part of the year, there's only one major meteor shower in early January, and we haven't had one since then, but we have one happening right now, the Lyrid meteor shower. And I think Nick is taking us very late in the night, early in the morning, because that is going to be the best time if you want to see Lyrid meteors. This is considered a major meteor shower, but adjust your expectations. You are not likely to see more than about 10 meteors in an hour. And that's if you're willing to go out between midnight and 5 a.m. So this does require some sacrifice. But if you wanted to go for the single best hour, assuming clear skies, you would want to be out between 4 and 5 in the morning. You can do this from right outside your house. You'll want to turn off any extra lights, especially exterior lights, outside lights, like yard lights, and maybe talk to your neighbors and see if they would be willing to turn off their lights as well so that you can get a darker sky and be more likely to see those streaks of light. They're called the Lyrids because they appear to radiate away from a direction that is near the constellation Lyra that the bright star Vega is part of. You do not need to know how to identify Lyra to see the meteors. They can appear in all parts of the sky. Okay, so I think that's pretty much what we wanted to tell you all, but we want to see if you all have any questions. So remember that if you have a question, to look down at the bottom of your screen and you'll see something that says Q&A. So click on that and you can type in your question and we'll try to get to at least a couple of those.
And
While
as you're thinking about those questions, I will point out one neat thing for you early risers before we take away our night sky. There's some planets that are going to be rising in the early morning. So Jupiter, Saturn, and Mars are going to be visible. Right now, this is the sky at about 4 a.m. But you'll notice they're still up in the sky as you get a little closer to 5:30, 6 a.m. And then our sunrise just a little after 6:30. So if you're an early riser, a couple things to check out as well. But like Amy said, we are excited to hear your questions. I see a couple of them popping in. So for now, I'm going to take down our screen and we'll try to find some of these questions.
Yeah, so Nick, we have a number of questions. Maybe we can tackle the ones about Venus first. We've got questions from Savannah and from Helen. One is, why is Venus so bright? And then another one is, how long will Venus be viewable in the night sky, or is it always viewable in the night sky? So Nick, which one do you want to tackle? And I can tackle the other one.
I can talk about why Venus is so bright. It has to do with both our sun and what Venus is made of. So Venus reflects a lot of sunlight. That's how we see planets in the sky. They're not like light bulbs or stars. They don't shine on their own. We only see planets because the sun's light bounces off of them. So sunlight's bouncing off of Venus, but it's especially bright because it's covered in clouds. Venus is covered in a really thick layer of clouds that help trap heat down at the surface of the planet, and those clouds turn out to be pretty reflective. So since it's one of the closer planets to the sun and it has a dense layer of clouds, it reflects a lot of sunlight back to us here on Earth, and that's why it appears so bright.
Okay, and then we've got another question from Helen about how long will Venus be in the night sky, or is it always in the night sky? It is not always in the night sky. So Venus orbits the sun, Earth orbits the sun. From our point of view on Earth, Venus will either be on one side of the sun or the other, or lost in its glare. Right now, it's on a side of the sun such that you will see it in the west after sunset for a number of weeks still to come. And then, so if you want to see Venus now, you need to get out after it gets dark, after sunset. And you can see it, it's so absurdly bright. You can see it pretty soon after sunset. But then, you know, in a while, as we move closer towards this summer, it's going to disappear in the sun's glare, and then it will pop up again in the early morning sky, and you'll see it in the east right before sunrise. And there's actually a story from West Central Africa about Venus being two wives of the moon. In this story, she's seen as an evening wife that he likes to hang out with in the western evening sky, and then the morning wife that he sometimes likes to hang out with in the morning skies. But he only thought he was married to two women. It was really just one Venus.
Great questions. While we're still on Venus for just a moment, I saw a couple of questions from Ruby and Savannah, or Ruby and Natalie. Is Venus on fire? And are there any days you're able to see Venus during the day? Well, Venus is not on fire, even though it's very hot. We say that Venus has a runaway greenhouse effect, which kind of means those clouds that I mentioned, heat from the sun gets trapped down at the surface of Venus by those clouds. So think about maybe your car on a really hot day. If you're in the car with your parents and you go into the grocery store, when you come back out, it might be a little hotter inside the car than it is outside because the windows are trapping heat. That's kind of how Venus's clouds trap heat as well. So even though it's not on fire, it is still very, very hot. And the other one was, are there any days that you're able to see Venus during the day? Do you want to talk about that, Amy?
Oh, well, I was going to add something about make a shameless plug for next week's Morehead at Home Skywatching. We're going to be taking a vacation through the solar system, and we will probably stop at Venus, but very briefly because Venus wants to kill us. And we will talk more about that next week. Venus during the day, technically, if you looked at exactly the right spot, you could see Venus in the daytime. I have seen it in the daytime. It is really hard to look in exactly the right spot. So I'd say don't count on it. By the way, every once in a while, Venus does pass directly across the face of the sun. And if you had a solar telescope, not an ordinary telescope, but a special telescope that's made for looking at the sun, you would see Venus as a black dot on the sun. But I have bad news. If you miss the last transit of Venus, that's what it's called, you don't have another shot until 2117. And the next time you'll see the transit of Venus from North Carolina is 2125. Okay, let's see. We might have time for another question or two. I see one about the meteor shower, the Lyrid meteor shower. Melissa asked, how long will you be able to see it? It actually runs through about April 25th, but it has a fairly short peak, and it really does look like early tomorrow morning, and the pre-dawn hours would be your best shot. So between midnight and roughly 5 a.m.
We have a couple of questions about Mars. Because I think I really briefly mentioned Mars. So if you are an early riser and you're curious about the red planet Mars, there's a question or two questions from Abigail. How long is Mars going to be up, and is Mars always up? So I'll answer the second one first and say that Mars is not always up in our sky, but it is always out there in space. It kind of has to do with how the orbits of the planets line up. So Mars is pulled into orbit around the sun just like the Earth, but Earth's orbit and Mars's orbit don't always line up exactly so that we can see it. But we can kind of predict where we'll be able to see it. So it's not going to be in the same spot every night. That's one of the big differences between how we see planets and how we see stars. Planets tend to kind of move through the sky in a different way. The word planet comes from a Greek word planetes, which means wanderer or wandering star. So ancient astronomers were able to notice that the planets move differently too. So all that being said, it's not always going to be in the same place, but there is kind of a region in the sky that maybe we'll talk about in our trip through the solar system next week, where we can predictably find the planets.
Okay, and I see a couple of questions that we can tie together that might make a great final question. There's a question about what is a new moon, and can you see stars better when it's new moon? So we're very close to new moon right now. So the moon orbits Earth, and it goes through phases as it does so. It takes about a month for the moon to orbit Earth. And right now we're coming in on close to new moon, which means the moon is in the same general line of sight with the sun. It's between Earth and the sun. It's the back side of the moon that's being illuminated, lit up by the sun, and the front side is dark, so we can't see it. And it's also up in the daytime because it's with the sun in the sky. So new moon is great for seeing stars. It's also great for seeing meteor showers. So that worked out really well for the peak of the Lyrid meteor shower this coming evening and into early morning. And also we will be doing a segment. Our next Morehead at Home Skywatching segment will be on the question of how dark is your sky. And if you join us on Thursday, we'll go over how to use your skills at using the Big Dipper to star hop to Leo, and using Leo to figure out how dark your sky is and how many stars you can see and how you can contribute to a worldwide citizen science campaign. All right, so with that, apologies if we didn't get to everybody's question. We hope you'll join us again, and we will see you Thursday, 10 a.m. Eastern. Thank you for joining us.
Thanks for joining.